Hola, la lección de hoy será en español.
Wow, Tibbs, your Spanish has really been improving. Although today's lesson is actually in English. You do remember that, right?
Sí.
I do see.
So today we're going to be talking about 1.7, factoring trinomials fully. So we've looked at different ways to factor thus far, right? We've started by pulling out GCFs, and then we progressed a little bit to factor by decomposition or factor by logical reasoning. And then last class we looked at factoring those special trinomials and our difference of squares, so those special quadratics. Today, we're going to be looking at all of those things tied together. So the first thing that we're always going to do is look for a GCF, and that GCF always must be removed first. And after that is done, we're going to look at our other methods to complete that factoring step. So we're going to jump right in and take a look at A. So if I'm looking at these three terms here, I notice that I have 3, 21, and 18 as my coefficients. Well, all three of those terms are divisible by 3, so I know my GCF will have a 3. When I'm looking at the variables, each of them have at least one x, so my GCF will also include an x. And if you recall from the beginning of this unit, when we're pulling out a GCF, we're dividing each term by that GCF. So 3x cubed divided by 3x would leave us with x squared. 21x squared divided by 3x would be 7x. And 18x divided by 3x would leave us with 6. Perfect. Now that we've done that GCF, we can look again, make sure we didn't just take out a CF. We want to make sure that our GCF is the actual greatest common factor, not just any common factor. So we're looking at that. Those three terms have nothing left in common. Nice. Once we've done that first step, the next thing that we're going to do is factor that remaining trinomial. And if you recall from last class, we said, well, let's look to see if it's anything special. We could tell that it's not a difference of squares. The dead giveaway is that there's 3 terms instead of 2. And it's not going to be a perfect square trinomial because although this first term is a perfect square, this last term is not. So we're going to factor that regularly, and we can use any method we so choose. Just maybe for this first question, I'll do it through decomp, and then later on, maybe I will do it through logical reasoning, just to kind of get everyone's preferences involved. So my first step in decomp is to use, or to find A times C, and A times C would be 1 times 6. It's no longer these values as my A and C, it's my factored or already factored trinomial. So I have 1 times 6, which is 6. And factors of 6 that will add to 7, well, I know that to be 6 and 1. So instead of 7x, I'm going to write 6x plus 1x. Notice that on each line, even though I'm continuing with the decomposition, I still have that GCF out in front. Because if I did not include it, it would not be equal from line to line. All right, carrying on. From here, I'm going to pull out the GCF out of my first chunk. That's going to be x, and I'll be left with x plus 6. And I'm going to pull out GCF from my second chunk, and that's just going to be a positive 1, and I'm again left with x plus 6. Another thing to keep in mind is that you want the same amount of opening brackets as you have closing brackets, right? If you do not have the same amount, that means you're missing one somewhere, and that could lead to a risky communication error.
And it's also very important that we do have this giant set of brackets encompassing everything as well, that we don't omit those. That ensures that this 3x out front will multiply the entirety of the rest of this polynomial, not just the first little bit of it.
Good tip. From here, when I'm looking at my decomp, I can see that my 2 brackets are the same there, so I know I'm on the right track. So I'm left with 3x, then I'm going to factor out that x plus 6. I'm going to be left with x plus 1. Woofed. And that there is going to be my final answer.
Oh, it's Christmas already.
I know, I was just thinking that. All right, that's number 1. Let's try number 2. If you haven't already, pause the video and see if you can pull out that GCF. When I'm looking for this GCF here, I notice that all of these numbers are divisible by 8, and it's the greatest common factor in terms of their coefficients. And then in terms of x's, well, they all have at least 4 x's, so I'm going to have x to the power of 4 included in my GCF as well. When I pull out my GCF, I'm dividing each term by 8x to the power of 4, so I'm going to be left with x squared minus 6x plus 9. I always draw my brackets too far. All right. Now, again, I'm going to see, is this special? Is this a difference of squares? And the answer is no, it's not a difference of squares. But why isn't it? Well, that's because we already have more than 2 terms. But is it a perfect square trinomial? Well, this guy here is a perfect square. Its square root is x. This guy here is a perfect square. Its square root of 3. And that b term, that should be 2 times the product of x and 3, which gives me 6x. And lo and behold, there we have that 6x. So yes, this is going to be, in fact, a perfect square trinomial. Perfect square trinomial. Which makes the factoring really easy. I was going to do it through logical reasoning, but now I don't have to because I know what's up. I'm going to have my binomial squared. My binomial, what's going to be included? Well, it's the square root of my first term, which is x, and then the square root of my second term, which is 3, and then the sine of my middle term, which is negative. And again, that is it for today.
Except for these other examples. Psych.
Got him.
I mean, them maybe. It didn't get me. I knew what was next. I checked out the notes. Pretty clever. Yeah, I'm going to maintain this Christmas theme colors-wise. I'm going to say this is equal to something, and I am going to extract the GCF. GCF between 80 and 5 is 5, and then x to the 12, x to the 8. The most I can take out is x to the 8, leaving me with 80 divided by 5 is 16. And x to the 12 divided by x to the 8 gives me x to the 4. And then 5x to the 8 divided by 5x to the 8 doesn't give me 0. Remember, there does have to be another term there still. It specifically gives me 1. So something divided by itself is always 1. I am not done. I look at this to check if it is factorable. And looking at it, I'm thinking yes, because it looks to me like a difference of squares. Specifically that, oh boy, I don't know how to use tools here. Figured it out. That 16x squared is the square of, 16x to the 4 is the square of 4x squared, and 1 is the square of 1. So as I go forward with this, I still have this 5x to the 8 out here, but it's being multiplied by something. Specifically, we got 4x squared plus 1 and 4x squared minus 1. And extra critical when you are factoring fully is that you still continue to check if you are completely done. Yes, we've extracted this 5x to the 8 as a GCF, and we've broken up this difference of squares into 2 pieces, but this right here is still a difference of squares, and that can be broken down even further. So we still have this 5x to the 8. A sum of squares can't be factored at all, so we'll leave that as it is. But here, 4x squared minus 1, we can break that down into 2x plus 1 and 2x minus 1. And this one is done. For this lastest one, back to grin. Looks like we've got 2 as common to all of these. So I'll factor out my 2. So I've got x squared and 7x and 14. Then I'll look to continue with this. And if I can, then I'd be able to set it up as these 2 binomials. And I'd be looking for factor pair of 14 that sums up to 7. However, none exist. We've got 1 and 14, we've got 2 and 7, that's it. So this actually can't be factored any further, which means I don't need that business there. And this is the final answer. So that's a little intro into factoring trinomials fully, and we've got a couple other cases to check out.
So what we looked at in these last 4 examples was we always had a positive GCF, right? But sometimes it's going to be a negative GCF, and that negative GCF that negative will only be extracted if your first coefficient, your leading coefficient, your ax squared term is negative. So if the leading coefficient is negative, your GCF is negative, okay? So this is going to be my leading coefficient here. This is going to be my leading coefficient here because, again, that is the greatest power of x in those terms. Alrighty, so looking at this first example here, I know I'm going to pull out a -1 because my leading coefficient is negative. But is there anything else I could pull out with it? Well, they don't all have x's in common. They don't all have other coefficients in common, so -1 is all I've got. And again, I don't have to write that -1. I could just write negative. It implies the same thing. If I wrote that 1, my answer would not be fully simplified. So I just want to have the negative out in front. Same as what I'm doing before. When I'm pulling out a negative, I am dividing each of my terms by that GCF. So I have negative x squared divided by -1, going to be positive x squared. Negative 7x divided by -1 is going to be positive 7x. Positive 60 divided by -1 is going to be negative 60. So we can see that our GCF being negative essentially switches all the signs of my terms, which is nice because every single time we factored, we did so using positive a value. All right. From here, I still have that negative. I'm going to factor through logical reasoning because I told you I would do that before, and I just never got the opportunity to. So here, let me pull it down a little bit and give myself some room. Whee! All right, put that bracket back. Whoosh. And let's draw my arcs. So my first, my outside, my insides, my lasts. I know my first terms will have to give me that x squared there. So I'm going to write x squared over my first term's arc. I know my last terms should multiply to give me that -60. So I'm going to put -60 over my last's arc. And my outside and my inside, my o's, well, I could figure those out by finding my a times c. So the factors of -60 that add to positive 7. And when I look for those, I think of positive 12 and -5. Right? Those add to positive 7 and multiply to give me -60. It doesn't matter where I put them. I could put the 12x on top and the -5x on the bottom. I could swap them. Doesn't quite matter. Okay, from here, to get that x squared, I know I'm going to need an x in each bracket. So I'll put an x here and an x there. Life is good. Next point, I'm looking at the x here times something will give me 12x. Well, that's going to give me a positive 12. And lastly, I know x times something will give me a -5x. And that is going to be a -5. This is actually going to be my final answer because I could see that my x minus 5 can no longer be factored and my x plus 12 can no longer be factored. So I could get rid of all these because those were the things that I was thinking in my head. Next example, same. We're going to look for that negative and we're going to pull that out because our leading term is negative. Okay, it doesn't really matter about our other terms. As long as our leading coefficient's negative, we're pulling that out. And I want my red back. All right. So I'm going to pull out a negative, but what else? This is divisible by 4. This is also divisible by 8. This is divisible by 4 and 8, and this is 8. So I'm going to pull out my number value of 8. I'm also going to pull out, I can't pull out an 8, sorry. That 28, I was thinking divisible by 7. Ha ha ha. So I'm going to pull out a 4. Now, for my variables, I could also pull out an x because each of those have at least one x in common. When I pull out a negative 4x reminder, I am dividing each term by the negative 4x, so I'm left with 4x squared minus 7x minus 2. And remember, when I'm pulling out a negative, all those signs flip. All right, from here, I am also going to do this via logical reasoning. It's my method of choice. And I am going to move this down a little bit so I can draw those arcs. This should be a 4x squared. This should be a negative 2. A times c gives me negative 8. They need to add to negative 7, so I'm going to have negative 8 and positive 1, negative 8x, and x. From here, I'm going to try putting, 4x and 1x, see if that works. Well, the 4x will help me here, nice. The 4x will help me there, nice. The x will help me there, nice. The x will help me here, nice. First try, look at that. All right, so from there I'm just kind of filling in the blanks. I know 4x times something will give me negative 8x, and that there should give me negative 2. And last but not least, x times something should give me x. Well, that something's got to be positive 1. And lo and behold, I reach my final answer. Let me get rid of those to draw in my final answer box. Wow, negative GCFs. Those are pretty cool. I bet that's the hardest we'll ever see.
Maybe, because even though the next thing's fractions, I don't necessarily think fractions are that hard. They look scary, but they're not necessarily that bad. We just have to get to know them a bit better. When we have fractions as part of the polynomial, as perhaps the coefficients or the values of a, b, or c, we will want to ideally factor things so that the fraction is no longer part of the main component of the trinomial itself. So what we're going to do is, well, there's a bunch of methods we can go with, but if we can get a common denominator on all the terms, then it makes the factoring process much simpler. One thing to note before we dive in, there was a little oopsie in the notes. So your notes will say that this is plus 5 over 2. It should be minus 5 over 2. So make sure you change that to a negative. So we have this polynomial, and it's got a half over here, it's got a half over here. This is 2 over 1. If we needed a common denominator, I'd want everything to be over 2. I can do that. Well, this first term is already something over 2. This last term is already something over 2. This middle term, if I want to say that 2 is something over 2, so we got something over 2 times x. That's a little cramped. Well, that would be 4 over 2. At this point, I can factor out the 1/2. What that will leave me with is just the numerators. Because when we factor something out, we're dividing by that value. We're dividing by then 1/2, which means we're multiplying each of these by 2. And that just crushes that denominator. So we're left with a single x squared. We are left with 4x. We are left with minus 5. That's that step done. And once again, now we're just at that stage of factoring whatever remains. So we've still got this 1/2 out here. I'm hoping, what's that arc about? I'm hoping that the rest of this factors. And there are factors of -5 that add up to +4. I know I have to start with an x and an x here. And it looks like I'm going to go with a +5 and a -1. Feel free to try the rest of the ones on this page. There's only 3 examples left in this lesson. I'm going to proceed with one more. Here I've got a denominator of 3 and 3 and then over 1. So I'll just convert those. So everything is over 3. We've got 1/3 x squared minus 1/3 of x minus something over 3. Something divided by 3 is 4. That must be 12. Therefore, I will take 1/3 of x squared minus x minus 12. So just the numerators are left. I'll keep the 1/3. I'll hope that I can factor the rest. X has to come from just x times x. And then 12, I've got options, but I really want to make sure this outside and inside product add up to, how you say, -1. And if I put something like, if I were to guess -6 and +2 or something, well, that doesn't give me that. That gives me this instead. So, whoop, bad choice. I'll try a different one then. Let's go with -4 and +3. Inside product is -4x. Outside product is 3x. The sum of that is -1x, which is certainly what we're after. So we're in business. This one is done. You're right. I should put beautiful boxes around all my final answers in all their majesty.
Alrighty. So as you could see in both those examples, the first thing we've done was start by getting everything into a common denominator. Let's continue down that path of success. So we can see that our denominator, right now we have the first term being over 1, the second term being over 6, and the last term being over 1. We want to turn those all to being a denominator of 6, because that's the lowest common multiple. Well, we could go ahead and do that by multiplying the top and the bottom by 6 of the two that don't have it. Alright, so this should give us -30x squared over 6 minus 25 over 6x plus 30 over 6. Okay, so I'm going to pull out the denominator in a single step here because that's what we've been looking at. We've been looking at pulling out that 1/6. So I'm going to go ahead and do that. And then I'm going to be left with -30x squared minus 25x plus 30. Now, I can see at this point that, well, 30, 25, and 30 are all divisible by 5. And my leading coefficient is still a negative. So I'm going to pull out another GCF. I actually didn't pull out the first GCF. I just pulled out a CF. I dealt with those fractions separately because we tend to confuse ourselves when we do too much at once. If you're capable of pulling all those GCFs out at once, you do you. But just for the ease of things, I like to deal with my fractions separately and then deal with the rest. So the next GCF here that I have would be -5. Okay. Maybe put that in brackets there. When I pull out a -5, I am going to be left with 6x minus plus 5x minus 6x. 6. Oh my goodness! Look at all the mistakes Ms. Thibodeau's making. Let's go back.
Catch yourself, so you're good.
When I take -30x squared and I'm dividing it by -5, I'm left with 6x squared. When I'm taking my -25x and dividing it by -5, I'm left with a +5x. When I take my +30, dividing it by -5, I'm left with a -6. All right, now we're cooking. Notice that at the beginning here, I have two GCFs, and they're just being multiplied by each other. So instead of writing it as that product, let's collect those two values. So 1/6 times -5 would actually give me -5/6. And I'll just rewrite this so we're only dealing with one thing at a time. So like I said before, we pulled out our fraction first, and then we pulled out our negative and our other possible coefficients or variables. You are capable, or it is possible that you could pull it all out at once and get that -5/6. It's a little bit more difficult, but I think that some of you and all of you can be capable to get there. Do what you feel. All right. At this point, I'm going to factor the rest if possible. I know that it's not a difference of squares because I don't have any perfect square terms as my first and last. And I know it's the same reason is not going to be a perfect square trinomial. First and last terms aren't perfect squares. So I'm going to look for my a times c value, which would give me negative 36. Factors of negative 36 that sum to 5. And so I see 9 and negative 4. Yeah? So from here, boop, I still have my GCF out in front. I'm going to logically reason this guy. And I'm going to do it this time, maybe without all of those arcs. Let's see what happens. So I know that my firsts need to multiply to give me that 6x squared. Well, what can go there? Well, maybe a 3x, maybe a 2x. I don't know. That's the first number that came to my head. Let's see if that works. Well, I know my lasts need to multiply to negative 6. You're right. I'm going to draw on these arcs. My insides and my outsides, well, I have 9x and negative 4x. Let's see if all of this works. So 3x will help me make that 9x. 3x will help me make that 6x squared. 2x will help me make that 6x squared. 2x will also help me make that negative 4x. It looks like my initial guess is correct. Heyo. Now I'm just filling in the missing blanks. So 3x times what gives me 9x? Well, that's going to be plus 3. And my 2x times what will give me negative 4x? That's going to be a negative 2. And I'm going to box my final answer. I was going to do it in green, but I switched to green halfway through. I'm going to box it in purple.
Basically the same thing.
All right. Last but not least, this beast. It's more of a beauty to me. So we're going to go ahead and make those all into common denominators. My common denominator, my lowest common denominator would be a 9. So I'm going to go ahead and multiply this first term top and bottom by 9, the second term top and bottom by 3, the last term I'm going to keep the same. So negative 2x squared times 9 will give me negative 18x squared over 9. Positive 32 times 3 will give me 96x over 3. Oh, not over 3, over 9. And lastly, this guy stays same. I'm going to pull out that 9, or 1/9, sorry. And when I do that, all my denominators disappear. It's kind of a large thing, a large bracket there. At this point, I'm going to look for other GCFs. I can see that my first term is negative, so I know I'm going to pull out a negative. I also might notice that all of these are divisible by 2. They're not divisible by 3 because although these sum up to 3, these digits also sum up to 15. These do not. These sum up... Oh, wait, hold up. Can I pull out more? No,
Yeah,
these sum
like
to 11. Yeah. So here we go. I'm going to pull out a 2, a negative 2. And when I do that, my signs are going to flop, and I'm going to get 9x squared minus 48x plus 64. And if I wasn't confident that I pulled out the GCF, I'm going to combine these GCFs here, I could still look and say, with my trinomial remaining, do I still have anything in common? I know that they don't have 2's in common. I know that they don't have 3's in common, so they're not going to have anything even. And there's no other things that are factors of 9. So I know that I've done my full job. But if I'm not confident in it, I could always pull out GCFs in multiple steps. So from here, let me take a look. Is this a difference of squares? No. Is it a perfect square trinomial? Maybe. This is a perfect square. That's a perfect square. Okay. Might be promising. Well, the square root of that is 3x. The square root of this is 8. To make it a perfect square trinomial, that's not enough. We need to make sure this middle term is 2 times 3x times 8. And is it? That gives me 6x times 8, which gives me 48x. Oh, and ooh, baby, there we go. What beauty, what grace. That is, in fact, going to be a perfect square trinomial, which makes my life super easy because I was not excited for multiplying that a times c value and finding the factors of that sum to negative 48. So I'm glad we recognize that. Because it is a perfect square trinomial, I know my first term is going to be the square root of my 9x squared, which is going to be 3x. My last term is going to be the square root of that 64, which is going to be 8. And my sign in the middle is going to be the sign of my bx term, which is a negative. And there she is. Or he. I will not assume its gender. And they are beautiful. All right. At the bottom here, there's only 3 questions for practice, so if you want to give those a go, that would be awesome. Anything you want to add?
Have a good day.
Yeah. And adios, muchachos.